In this video, we will be extending our look at trigonometry into the circular functions. This is so that we can look at obtuse angles and even negative angles. We'll start off with some of the terminology we're going to use with our angles. On an angle, we'll have an initial side and we'll have a terminal side. We will measure from the initial side around the angle of rotation to the terminal side. We're going to be using Greek letters to denote the angle. This one is alpha. When we are talking about positive angles and negative angles, we're talking about the direction of rotation. A positive angle, all the angles will be starting on the positive x-axis. A positive angle will rotate around counterclockwise, and a negative angle will start in the same position and rotate in a clockwise direction. Another Greek letter here, we have beta. We can have two or more angles that have the same initial side and the same terminal side, but have different measures. We can have the initial measure be this angle. We can have the initial measure go all the way around and then come to the terminal side, and we can go negative. So we still start at the initial side and we go around to the terminal side. So all three of those angles are coterminal. Coterminal, they terminate at the same spot. So let's find a positive angle and a negative angle that are both coterminal with 45 degrees. So if we have our x and y axis and a 45-degree angle, we can have an angle that goes all the way around, which would be 360 plus 45, which would be 405 degrees. Or we could have, starting at the initial side and going around to the negative to 45, that would be 45 minus 360. We know, because we know it's a negative, so that's going to give us negative 315 degrees. So 45, 405, and negative 315 are all coterminal angles. If we want to find a coterminal angle with radians, we know that in a circle there are 2 pi radians. So to find coterminal angles, we can have pi over 6 plus 2 pi, and getting a common denominator, that'd be 12 pi over 6 equals 13 pi over 6. So that would be one of the positive coterminal angles. Get a negative angle, we would have pi over 6 minus 2 pi, again getting a common denominator. This will give us a negative 11 pi over 6. So pi over 6, 13 pi over 6, and negative 11 pi over 6 are all coterminal. Say we are given a point in the first quadrant, and that point, if we draw a line to it, will form an angle, and we want to find all 6 trig functions for that angle. So if we have the point 3, 5 in the first quadrant, so here's our point. We'll draw the terminal side. We're coming around there. To draw this, we're going to drop a perpendicular line at a right angle from that point, and now we have a right triangle, and theta here is the angle we're going to try and find. So this is length 3, length 5, and then we want to find the radius, which is the hypotenuse. 3 squared plus 5 squared equals c squared. 9 plus 25 is c squared. 34 equals c squared. So c is square root of 34. So that is our radius. So now we want to find all 6 trig functions. We can start off by remembering SOHCAHTOA, and until you have this in your head, you might want to just write it on your paper for a little while. Just start getting into your head. So sine is opposite over hypotenuse. Theta is here, so opposite over hypotenuse. Sine theta equals 5 over square root of 34, which is, if you put that in your calculator, is approximately 0.857. Cosine of theta, adjacent over hypotenuse. Adjacent is 3, so it's 3 over 34. Putting that into your calculators, 3 divided by the square root of 34 equals approximately 0.514. And I say approximately because it continues on and on. We're just rounding it. So it's not an exact answer. 3 over square root 34, although it's not rationalized, it is an exact answer. So tangent of theta, tangent is opposite over adjacent, so that's going to be 5 over 3. That's the first 3. The second 3 are going to be the reciprocals. So cosecant is going to be square root of 34 over 5. Secant theta is square root of 34 over 3. And cotangent of theta is 3 over 5. So here we have another way to look at the trig functions. We've got the same triangle here, 3, 5, square root of 34. Sine, which is the opposite over the hypotenuse, is also the y value over the radius. Cosine, which was the adjacent over the hypotenuse, is also the x value over the hypotenuse, over the radius. And tangent, which is the opposite over the adjacent, is the y value over the x value. Let's find the sine of 210 degrees without a calculator. So 210 degrees, what do we know about 210? Well, we know that 180 degrees is a straight line. So let's take away 180 degrees from that, and we're left with 30. So here's 180. We need 30 more degrees to get to 210 degrees around. So that one is 210 degrees. If on this, from this 30, we bring a line straight down, gives us a 90, we now have a 30, 60, 90 triangle, which I'll draw over here. This is our 30, and this is our 60, and this is our 90. We know the ratios of the 30, 60, 90 triangle are 1 to square root of 3. So we'll use that to find the sides of the triangle and the trig functions. All we're looking for here is a sine function. We know that we're looking for sine of 30 here. This is called a reference triangle. It's called a reference triangle because it's not exactly the 210 degrees. We're looking at the 30 degrees. So sine of 30 degrees is the opposite over the hypotenuse. So sine of 30 degrees is 1/2. But we didn't ask for the sine of 30 degrees. We asked for the sine of 210 degrees. So the only thing that's different from that will be the sign, S-I-G-N, the sign of the sine. And by the way, this is how you spell sine. Sin is an abbreviation. Sine is with an E. So sine of 210 degrees, the sine is y over the radius. In the third quadrant, the sine, the y value is negative. The radius will always be positive. It's a distance. It will always be positive. So here we have sine of 210 degrees will be negative 1/2. Now we're going to use one trig ratio, to find the others. So we'll start with cosine of negative 8/17, and we want to find the cosine, sine, and cotangent of theta. So let's start by drawing a picture. Negative 8/17, what do we know about the cosine? We know that to draw our reference triangle, we need to figure out where we are in our axis. We know that cosine is the x over the radius. We know the radius is positive, so the negative has to go with the x. So we're going to be coming out 8. Cosecant is 1 over sine, so it's less than 0. So the sine is going to be negative. The y is going to be negative. So we're coming down a certain amount, and we know the radius is 17. So we're coming out 17 and negative 8. We want to figure out this value there. So we have dropping our perpendicular line gives us a right triangle. We have theta there. To figure out the distance there, we'll use the Pythagorean theorem. So 8 squared plus b squared equals 17 squared. If you calculate that, we'll get b is equal to 15. And on this reference triangle, we have a negative 15. So now that we have our triangle set up, we can find our sine and cotangent. Sine is going to be the y value over the radius. So that's negative 15 over sine of theta equals negative 15 over 17. The tangent is the opposite over adjacent, which is negative 15 over negative 8, or 15/8. So that cotangent is going to be the reciprocal of that, or 8/15. In our second triangle, we've got a tangent is a negative number. Tangent is going to be the y over the x. In this case, we don't know which one's the positive and which one's negative. They have to be opposite signs to end up with a negative. We do know, however, the cosine is positive, and the cosine is the x over the radius. So we know that then the y has to be the negative one. So we draw our reference triangle. We go down 1 for y and over 2 for x. So there's our point. Drawing the reference triangle up to the x-axis. So we have 2, 1, and our unknown. We use the Pythagorean theorem again. 2 squared plus 1 squared is equal to c squared. 4 plus 1 is equal to c squared. So c squared, c is root 5. So I'll redraw that. Here's our theta. We had the x value of 2, the y value of 1, and root 5 for the radius. So we want to find sine, and we know the sine is going to be negative. Cotangent is going to be, well, we'll get to that in a sec. So sine is going to be the opposite over the hypotenuse, which was 1 over root 5. And remember, we had the 1 was negative. So rationalizing this, we'll get negative root 5 over 5. Cotangent, we don't even need this. Cotangent, if tangent is negative 1/2, our cotangent is going to be negative 2. And now, just for fun, see you in class.